Here's another one, same kind of layout, arsenic, except what do you see here? You see very little difference between the urban fixed site and the upwind fixed site, and very little spatial variability on any given day. Now, in both of these plots, you do see that everything seems to go up and down, and that's indeed true, that there's big ups and downs. What do you think causes the big up and downs in air pollution in New York City? Do you think the sources are changing day to day? So for the cobalt, we burn more fuel oil on this day than on that day? What's that? It was winter, so on a colder day we might burn more fuel oil. That's one reason. What's another reason? What? Weather. Yes, weather is by far the dominant influence on air pollution concentrations. You see that in New York City. We have a weekly weather pattern. So about once a week we get this cold front that moves through, and it's like today. It's beautiful, clear, it's fantastic. And then the weather system stalls and the air pollution begins to build up and up and up. So we see that in air pollution in New York City too, that the weather has a major influence. In Beijing, they've made all these horrible things. Well, they tried to do a lot to reduce the air pollution, and yet what they didn't understand was that it's the weather that controls the air pollution there, whether it's blowing from the south or blowing from the north. And so there wasn't much control they could do unless they shut all the factories to the south. And they didn't think of doing that. They tried just to control the local sources within Beijing, and that had very little effect. It just depends on whether the wind is coming from the north or coming from the south, and whether it's blowing fast or whether it's just sitting there and letting the pollutants build up. So the interpretation of the arsenic data is that it comes from an upwind source, and that's why it's the same everywhere. And so just looking at the data in this temporal, spatial way, it can tell you a lot about the local sources. Arsenic comes from coal combustion, and most of the coal combustion is done in the Ohio Valley and flows into this area, bringing trace amounts of arsenic, but also bringing quite a bit of sulfate and quite a bit of which comprises about half of the mass of the particulate matter that we breathe in New York City. So now that you're all experts, so here's another air pollutant. This is actually absorbance, which is just an optical measurement for black carbon. So is this upwind source or a local source? Okay, I've heard both upwind and local. Why do you think it's, who said upwind and why? No? Who said local and why?
I said local because there isn't that much distribution of the points in the second graph.
So there wasn't a lot of scatter? Well, okay, so we have both, and here we have both winter and summer. So in the winter, is there more scatter or less scatter at any one point in time? More scatter. And in the summer, there's less. My computer is dying. Certainly, so if there's a lot of scatter, that would be local. Less scattered, there would be more upwind air sources. So certainly in the winter, there's a lot of sources of black carbon. In the summer, with less scatter, there's less local sources. Black carbon is from incomplete combustion, so all the heating of your homes, and also from traffic, a lot from diesel traffic. So there's still some scatter in the summer, but there's more when you have both heating and the traffic in the winter. This graph tries to summarize all the different air pollutants we measured into one graph by just looking at the ratio of the city median, the city air pollution levels to the upwind air pollution levels, plotted for all the different things we measured. If the ratio is near 1, that's saying that the city was very similar to upwind, thus upwind air sources. When it was elevated well above 1, that means there was a big difference, and thus local sources were important. So this way we can identify a lot of pollutants that are of local importance and which ones are blowing in from upwind. And we can do that for the elements and the particles, and we can do that for the solvents, the VOCs. So MTBE, does anyone know what MTBE is in? MTBE is a fuel additive that was used back in the late 90s. And so, do we have a lot of traffic in New York City? Yeah. So does it make sense that it's well above a ratio of 1? Yes. Okay. So that's kind of what we were doing there. The other important thing that we looked at, since we had data both inside and outside the home, we could see whether the home was an important source. This will eventually show up as well. So here we have all the different VOCs plotted and aldehyde concentrations plotted. And what we're plotting on the y-axis is the ratio of the indoor level to the outdoor level. So here again, if the indoor to outdoor level is near to 1, then the concentrations are the same inside and outside the home. And that's probably, the source is probably outside of the home. If the ratio is well above 1, then there's probably a lot of sources inside the home. And this is plotted on a log scale, so the line is 1, but it quickly gets above 1 as you go up because of the log scale. So we can see that for VOCs, chloroform was the one in both seasons, both winter and summer, that had the highest ratio. So how do you think where's the chloroform coming from inside your house? Any ideas? Refrigerants? Okay, that's one idea. Another idea? What's that? Heating, okay. What do we do to our drinking water to make sure we don't get really sick? What's that? We filter it. What else do we do? Purify. How do we purify it? How do we kill the bacteria? What's that? Well, we can boil it. You boil every glass of water that you get before you drink it? Well, what do we do in New York City to make sure that people don't get sick when you're drinking a glass of water? And what do they treat it with? Chlorine. Guess what a byproduct of chlorine is? A byproduct of chlorine, some small percentage, forms chloroform. It's in our drinking water. So where do you think we get most of our chloroform exposure from? From hanging out inside our homes, but even better than that is when we take a shower, right? Because we're sitting there with the hot water, it's degassing all this chloroform. In that short shower, you're exposed to the vast majority of the chloroform that you breathe in a single day.